Quality education is a human right.
Hi guys, today we're going to learn the derivative of trig functions. First thing we're going to do is graph the derivative sign, and we are going to first find where sine of x has an instantaneous slope of 0. And as we learned with David, that when pi over 2, when x equals pi over 2, the instantaneous slope of sine is 0. And then there's an also when when x equals 3 over pi over 2, there's also an instantaneous slope of 0. And since there's an instantaneous slope of 0 when x equals pi over 2 and 3 pi over 2, the roots of the derivative of sine of x will be pi over 2 and 3 pi over 2. Next, we could see that when x equals 0 at sine, we can see that there's an instantaneous slope of 1 and also an instantaneous slope of 2 pi, 2 pi, sorry. And so the same thing we did with this instantaneous slope of 0, we will graph these on the derivative of sine as 1s. Lastly, we can see that at pi, we can see that the instantaneous slope of sine at pi is -1. And since the instantaneous slope of sine at pi is -1, we will graph on the derivative that when x equals pi, it equals -1. Lastly, we just have to graph the function. And so we could see that when x equals 0, we can see that the instantaneous slope at sine is 1 and it goes to 0. So that means the slopes as we get to pi over 2 are decreasing. So we will do the same. It's going to decrease. Now we're going to start from pi over 2 to pi, and we have an instantaneous slope at 0 at pi, and then it was an instantaneous slope at pi is -1. So 0 to -1 is a decrease, so we will also decrease again. And then we're going to start from pi, which has an instantaneous slope of 0, and then we're going to go to 3 pi over 2, which has 0, so then it's an increase. -1 to 0 is an increase. Lastly, we are going to see that this has an instantaneous slope of 0, and it goes to 1, so then again, it's another increase. And that is the derivative of sine on a graph. But we can also see, we also notice that the derivative of sine on the graph is just this cosine of x. So now we'll be graphing the derivative of cosine. So as we did before, we are going to find where the instantaneous slope is 0 on cosine. And there are 3 points at 0, 2 pi, and pi. And so we will graph these on the derivative as zeros. And then pi over 2, we could see that, we could see that there's an instantaneous slope of -1. So on the derivative, we will graph this as -1. And then at 3 pi over 2, we have an instantaneous slope of +1. And so on the derivative, we're going to point out the +1. And so now we just have to connect the lines like we did before. And 0 to -1 is a decrease. So we will decrease. Then pi over 2 to 0 is an increase. So we will also increase. 0 to positive 1 is an increase, and 1 to 0 is a decrease. And so the derivative of cosine, you can notice that it looks like sine. It's just that the derivative of cosine, the sign is just flipped on its x-axis, which means that the derivative of cosine is really important. The derivative of cosine is just negative sine of x. Now we will summarize what we have learned so far. Okay. So as we saw the derivative of sine is cosine of x, and the derivative of cosine is just sine, but flipped on this x-axis, so it is negative sine. And lastly, we won't be learning how to graph tangent today, but it's still great to have these three memorized, since these three are very common in calculus. So the derivative of tangent is just secant squared of x. And for those who don't remember, secant is just the reciprocal of cosine. All right, guys. You guys can pause the video if you want to jot these down, and if you already have them jotted down, then we can move on to the practice problems. The first problem here is the derivative of 9 sine of x, which the coefficient of a function just is the same while we're doing the derivative. So 9 just goes to 9. And then we have sine, which, remember from last slide, is just cosine of x. And so your answer is 9 cosine of x. Now for the second one, I want you guys to try it on your own. You can pause me and come back when you finished. All right. So now that you've done it, first we're going to start with a 3. So as you remember, the 3 just transfers and stays the same. And then we're going to do the cosine, which we learned from last slide, is just negative sine of x. And lastly, we have the 7, the constant, which, remember, it just becomes plus 0. And so we don't really need that there, so we're just going to get rid of it. And then we just have to distribute the 3. And so that becomes negative 3 sine of x. Now we're going to do more examples like this, but with product rule. All right, for these problems, we will be using product rule, as you learned with George. Here's the rule. And for the first problem, we will use cosine of x as f of x, and sine of x as g of x. So the first thing we're going to do is find the derivative of cosine of x, which is, if you remember, sine of x, negative sine of x, sorry. And then we just bring over the g of x, which is sine of x, so sine of x stays the same, plus cosine of x, since it stays the same in the rule. And then we find the derivative of sine of x, which is just cosine of x. And so after that, we just need to simplify and combine like terms. And so this becomes sine of x times sine of x, and negative sine of x times sine of x, which is just negative sine of x squared. And then plus cosine of x again squared. Now, most people realize or see that this looks similar to a trig identity, which is sine squared of x plus 2 cosine squared of x equals 1. But as you can see that we do not have a positive sign. Instead of, we have a negative sign, and so negative sine squared of x plus cosine of x does not equal 1. And so for the next question, I want you guys to try it on your own. You can use at 7 tangent of x as f of x, and cosine of x as g of x. Come back, pause me, and then come back when you're done. All right. Now, the first thing we need to do is find the derivative of 7 tangent of x, which is 7. Remember, the derivative of tangent is secant squared. So, secant squared. Let me just bring over the cosine. Cosine of x plus, now we just leave the tangent, the 7 tangent. Bring it over, and now we find the derivative of cosine, which is sine of x. Now, we just have to simplify. Now, for this side, we do not need to simplify. It stays the same. Right? Stays the same. And for this side, we could do 7 tangent of x times negative sine of x, which just brings the negative in front. Sorry. And that is your answer for the derivative of 7 tangent of x times cosine of x. Next, we will be using the quotient rule. All right, guys. For this one, we're going to be quotient rule. Remember, we learned that with George. And so for the first problem, first problem we have here is we are going to be using sine of x as f of x and cosine of x as g of x. So go try it on your own, pause me, and when you're finished, come back. All right, so now we are going to solve this derivative. So the first thing we need to do is find the derivative of sine, which is, if you remember, cosine of x. Cosine of x. And then we just bring cosine of x again, since g just brings over. And so g of x just brings over, sorry. And now remember, guys, that for the product rule, it's plus, but for quotient rule, we have a minus, right? Don't forget that. And so for sine of x, well, for f of x, we just bring over the sine of x. And then for g prime of x, remember, it is negative sine of x. And now we just need to do the bottom. Oh, sorry. Same color. Bottom, which then becomes cosine of x squared. Now, all we have to do is just simplify it. So cosine times cosine is cosine of x squared. Now, negative sign times negative sign, well, negative times negative makes a positive, so we're going to put plus. And then sine times sine is just sine of x squared. Now for the bottom, it stays the same. Cosine of x squared. There you go. And now as you remember from last one, that the trig identity that we talked about, which you can see is right here. And so remember that cosine squared plus sine squared of x is just equal to 1. So we can simplify that as 1 over cosine squared. Oh, sorry. Let's not make that right. Cosine of x squared. Now, if remember again that cosine, 1 over cosine, is just the same thing as secant. But since there's 1 over cosine squared, we are going to put secant squared of x. Now, there's also an important thing we can notice. Remember that in pre-calc, we learned that tangent is equal to sine over cosine. So we just proved that the derivative of the derivative of tangent is actually secant of x squared. Look at that. All right. Bear with me, guys. We have one more topic. We're going to talk about chain rule. All right, guys. We're going to be using chain rule right here, which is right here. We learned that with George. Remember that. And we're going to be starting with this one because I know a lot of students would mess up doing this one, so I just want to clarify. So, what we're going to do first is we're going to rewrite this into cosine of x squared. That just makes things a little bit easier so we can actually solve. So as we can see in the chain rule that the outer function is f of x, right? And so the outer function here would be the squared, and so the inner function would be g of x, which you can see is the cosine of x. And so what we're going to do first is the f. So this would then equal to 2. We're going to bring down the 2 since we're doing derivatives. We're going to bring down the 2 and put cosine of x because, as you can see, we used to do the derivative of the outer function first, and then we leave the inner function. And then we're going to do the inner function. So times negative sine of x. And so all we have to do is now just simplify. So 2 times negative 1 is just negative 2, since we got the negative from the negative sign. Then cosine of x, and then times sine of x. And that is your answer for the derivative of cosine squared of x. Now, I want you guys to try this one on your own. Remember, use chain rule, and cosine is your g of x, and sine is your f of x. So come back when you have done the problem. Pause me, and then come back when you're done the problem. All right. So first thing we're going to do is find derivative of sine, so we do according to the chain rule. Right, so the derivative of cosine, sine is cosine. And so we just leave the inside, cosine of x. And then we find the derivative of the inner function, which is negative sine of x. And so to simplify this, we're just going to put the negative in front. Cosine of x, and then times sine of x. And that is your answer for the derivative of sine of cosine of x. And these are ways that you may see trig functions being used in calculus.
If you have any questions or any practice problems you would like to understand better, please comment them down below. During our bi-weekly Q&A, we will tackle these problems from the comment section.
Please like and subscribe so that our videos can reach more calculus students. See you next time, you sleuths.